Hi all, this is Honey. Welcome back to our channel Code with Honey. Today we are going to solve September Day 20 LeetCode challenge, which is implement router. So we have to design a data structure that can efficiently manage data packets in a network router. So each data packet will consist of source, destination, and a timestamp. So they will be giving you a memory limit, okay, of the router. So that's a fixed memory limit that won't change. So you have to add packets and forward pack. You have to do this operation on the router, which is add, forward, and get count. Okay, add packet is nothing but you will be adding the packet to the router. So since it's a fixed limit, so if we are adding new packet would exceed this limit, we have to remove the oldest packet, so which means which got inserted at the first. Okay, if a packet is considered duplicate, if another packet is with the same source, destination, and timestamp, so and you should not add the duplicate packets to the router. We should return true only if the packet is successfully added to the router. That should not be a duplicate packet. Got it? So if we don't have the memory limit, what we should do, we should call the forward packet, or we have to remove the first packet which got inserted from the list, so that we'll have a space for the new packet which is going to get added. So forward packet is nothing but forwards the next packet in first out, so which will be like we are removing the packet from the storage which inserted first. So when the packet exceeds this limit, we should just straight away call the forward packet that will remove the first packet which got inserted. So we have to just implement the forward packet to use it in both places when the memory limit exceed case, as well as the when forward packet is gets called. So get counters, will be having destination, start time, and end time. So we have to return the number of packets currently stored in the router having the specified destination that falls in between the timestamp which they have given as a start time and end time. Got it? So here if you see, they're given destination as a 5 and 100 and 110. So what all having destination 5, 1, 2, 3 packets, right? But only one packet falls between the range 100 and 110. You have to return the count of this. Okay, I hope you guys would have understood the question. Let's take a look how we are going to approach. So yeah, this is the same set of queries that they have passed, and according to that we have according to the add packet, forward packet, and get count, we have, when the particular function is getting called, we have to perform the operation as per the condition they have mentioned in the question. So yeah, this is the add packet. These all I have added here for reference when we are writing the function. So yeah, first initially as we have told, forward packet, which means we have to return the first inserted packet. And when we have a duplicate, so when we have the same, when we when we are calling the add packet with some source, destination, and timestamp, and it exits the memory limit, that time also you have to remove the oldest packet. Oldest packet means which would have inserted in the list at first. So it both performs the same first in first out. When the memory limit exit as well as the forward packet, we have to remove the first in, okay, whatever the packet that got inserted at first. So to remove first 10, what is the data structure that we will use, which is a queue, right? So yeah, basically when you're adding the packet, you should insert at the end of the queue. When you're removing, you should remove it from the start of the queue. So that's what we will be doing on initialization. So initialization will be getting memory limit, right? So self dot dq will initialize, that will be the dq to perform our insertion and forward packet operation, and we'll be having self dot route hash map, that is in the set, okay, to check whether that same source destination already present. At order of 1 we are using the set. Got it? We have to have the memory limit. Okay, these are the three functions that we will initialize on initialization of the router class. Okay, now we will be calling it def add packet. So add packet will consist of source, destination and timestamp. So you will create a tuple of this. So if there are three things, remove old packet if exits the memory limit. Before that we will be checking whether that is a duplicate. Okay, if it's not duplicate only, we are going to insert, right? So we'll be checking if packet in self dot router hash map. So then you can straight away return false because that's not going to get inserted, right? So next, if okay, now another case you have to check is remove hold packet if exits the memory limit. So if self dot dq length equals to self dot memory limit, so which means it occupied all the space of the memory. Now we have to just call the self dot forward packet that will remove the oldest packet. Got it? So once it got removed the oldest packet from the queue, now you will have one more space. You will be just appending that to the self dot dq dot append your packet, then self dot router hash map. Also you should add the packet so that will be used for the comparison. And you successfully got added. Now you can return true. Okay, these are the two functions which will be used for initialization and adding the packets to the queue. Now next take a look at the forward packet. Basically you have to remove the first packet which got inserted. So what we will be doing, if queue is exist, what you will be doing, you will be removing the first. So the packet is self dot dq dot pop left. You have removed the first packet. Now we have to remove from the router hash map set. You can just call remove and you pass the corresponding value that will get removed at order of 1. Now you have removed, since forward packet function wants us to return a source destination of the timestamp. So what we will be doing, you will be returning the list. Since it's a tuple, you will be converting it to a list of packet, which now it will return as array. If not, you have to return a empty array. That's what. If there is no packet, you have to return it as a empty array. So yeah, this is the forward packet function. So when the memory limit exceeded also, you'll call this. So it will remove the first one from the DQ. So you will have a space for the new packets which is going to add it, get. And if you call the forward packet, you will be just returning it. So this serves both the purpose. Now we'll just take a look at the get count function. So get count, you will be having a destination and the start time and end time. These are the three things that you will be getting. So on get count, you will be checking if we'll be having a count as a 0. For we'll be in that DQ, what all will be having source, destination and timestamp. We'll be having 3, right, in self dot DQ. So for each DQ value, we'll have source, destination and timestamp. If the destination are equal and the timestamp is false between the start time and end time, then okay, this you should take a count. For example, here 100 and 110, the destination is 5. So we will be traversing through all the packets which are 1425, 3595, 45105. All these things will be there, right? Among this, only one falls between this timestamp. So the destination should be equal to the destination which they have given, and timestamp falls between those. Then you will be adding the count of 1, and in turn, once you have traversed all the values, you will know the count of the destination that falls between the given period. Got it? So then you will be returning the count. So yeah, this is the exact solution that we have used to solve the given question. So now let's look into the time complexity and the space complexity. So here, as we have discussed, initialization will have DQ and fast lookup. We are using a set to use a fast lookup and to avoid duplicates. So, and this is the memory limit we are assigning so that we can check whether the memory limit of the DQ is full or not. Got it? So add packet. This is the packet, right, which will have source, destination, timestamp. So if the packet in already present in the map, then it's a duplicate. So you have to return false. If not, we have to check another case whether that reaches the memory limit. If the memory limit is reaches, we have to call the forward packet to remove the oldest packet. Oldest packet is nothing but which got inserted at first. So the same first in first out concept for the forward packet they have mentioned, right? You have to remove the first inserted packet. So here oldest packet they told to remove, thus both are same. So we are just calling the forward packet here to remove the packet, and we are removing it from the router hash map to have a sync between the DQ and router hash map. So yeah, once you have removed the packet, now you have a space to open new packet and update the router hash map accordingly and return the true because it got successfully added. So as we discussed earlier, forward packet is just removing the first packet which got inserted. Count as like whatever the destination source is equal and the corresponding timestamp fall between the start time and end time, then you are incrementing the count and returning the count at the end, number of the packets that falls between the start time and end time. So if you just take a look at the time complexity, so add packet is basically we are performing all the operation at order of one, because set also, since your router hash map uses set, it will do it order of one. Here also order of one, because pop left will have a pointer at the left which will pop. Okay, and the get count alone will be order of n, as we are traversing through all the packets to find the destination is the given destination, and we are checking the timestamp is between the start time and end time. So only this will be the order of n. Optimize this. Okay, we can use binary search and have the destination map timestamp. What all the you will have a corresponding destination for 5, what all the timestamp, for 6, what all the timestamp, and this will be in a sorted list. So based on the start time and end time, the difference between the start time and end time which we are going to insert, based on the index, we will be knowing how many timestamps falls between in that range. Okay, by then we can optimize this, okay, to order of log n. But since you have that you have to do only if there will be a frequent calls to the get count rather than add packets and forward packets, because you will be going to have an additional map called destination map that will hold all the timestamp of the corresponding destination, which is a sorted list. Okay, so whenever you are we have tell here everything was same. In addition to that, we will be updating the destination map. So self dot destination map of destination equals to, you are initializing when the destination was not there, you are initializing with a sorted list, and you are adding that to a adding the timestamp to the destination map. Since it's a sorted list, you will take order of log n to for this insertion. So now from order of 1, the forward add packets will be having a time complexity order of log n. Okay, this time complexity will get increased. The same when you are removing also, you have to remove it from the destination map as well, right? So yeah, source, destination and timestamp you will be getting from the packet. So the destination is present in the destination map, we have to remove. To remove that, again, since it's a sorted list, you will be having taking a order of log n to remove it from the destination map. So if the corresponding destination has empty array, then you are removing it from the grid. This is all the basic hash map operation. Since it's a sort hash map, in turn has a sorted list, we'll be to insert and pop it out, we'll be taking order of login, right? So yeah, then get count will be for get count from order of n to it will go order of login. So I'll show you the guys example. So here if you see the destination is 5 and the start time is 100 and the end time is 1 not, so 1 time. So let's assume 5 has key 90, 95, 102, 105, 109. We will be getting a count of 3. Okay, so timestamp we got. This is the timestamps. Okay, so now we are, since it's a sorted, you can do bisect left to get of the start time where 100 will be getting inserted here. So it will be returning you the index 2. So 100 will get inserted here and 110 will be inserted at the end, right? So 2 and you will be getting 5. So here 0, 1, 2, 3, 4. So you'll be getting for 100 bisect left as 2 and 110 bisect right. So you will be getting as a 5. So 5 minus 2 you will be getting 3. So yeah, at 2 this will take log n and this will take another log n to find out what are the left and right indices. So if you subtract that, you will be getting count of the destination whose timestamp falls between the start time and end time. Got it? So yeah, now if both the approaches will be successfully get submitted, if you submit any of the solution, you will all the code test cases will pass. But only difference here is if the get count will be calling more compared to the add packet and forward packet, it's better to use this approach where we'll be having additional order of n is nothing but memory limit. So to the max we'll be storing all this values which will have only length of the memory limit. So to the max we will be storing order of memory limit, right? So once the memory limit exited, we will be removing. If the get count will be called more, then it's better to use this approach. If not, it's better to use this approach. Here we will be having additional order of n space complexity and forward packet and add packet will be having additional time complexity log n. So yeah, both approaches has its pros and cons according to the use case. I hope this makes sense. So if you have any questions or feedback, please feel free to leave a comment below. I'll be glad to assist. I'll be providing the links to the solutions in the video description for your reference. You can check it out. If you found this video helpful, I would truly appreciate if you could like, subscribe and share it with your friends. Your support means a lot and it will motivate me to do more videos daily here. Thanks for watching.